My name is Pawel Rohleder. I'm CTO at Techland, and CTO means I'm not doing the code anymore, which I miss a lot. I'm just fostering the creative space for other developers to make code, and I hope they're doing a better job than I did in the past. Besides that, the CTO job is to create a strategy for technology, and current strategy for Techland is to make more than one AAA title at the same time. For like 20, 25 years, we were making only one title at a time, and technology was tailored for this one title. This time we take the decision, okay, let's make it shareable tech and make more than one at the same time. Before we can start, this is the takeaway for the talk. So I wanted to tell you about two things that we specifically learned for over the last 2 years. So how to set up the programming environment to really support this kind of a setup. So how to develop the tech and how to use the tech simultaneously when working on two AAA pipelines at the same time. Plus, what are the best practices that we learned from that process. So some practices how to manage the programming teams in terms of 80 programmers working in the same environment. So the agenda is as follows. First, I'll tell you a little bit about our setup and when we start when working on Dying Light 1, and then how we moved in Dying Light 2 and the other AAA title that I'm not allowed to talk about more, but still from the tech perspective, I'll give you a little bit of insights of that. Then we'll see what is the bumpy road of trunk-based development and how we make that road from trunk-based development through feature streams to trunk-based development again, but in a different form. Then I'll present you our current solution, and the solution is here, but I made the image small enough that you couldn't see it right now, that you need to stay for the rest of the presentation. In the second part of the presentation, I'll show the lessons learned that we extracted from this experience. And at the end of the talk is supposed to be 35 to 40 minutes. We'll have the Q&A session, so if you have any questions during the presentation, please write them down and ask at the end. Before we start, I'll give you a little bit of background what are our setups. So when switching from one project to multiple projects, because switching from 1 to 2 is probably harder than from 2 to 5, because it's changing like the different approach in mentality and whatever. There are 3 major challenges if you find in this situation like that in your company, whether it's small or big. The first challenge is the architecture and the engine architecture. We've been doing one game and one tech for 25 years. So as you could imagine, the architecture isn't ready for creating more than one title at the same time, sharing the same tech. So the engine itself, the architecture, how it's being developed, how it's being pushed into production environment is a challenge. The second thing is the technical production or technical direction, so how the programmers should work in this setup. And this presentation will cover like majority of this part. And the third important part is the mentality. So right now, there is like no possibility for a programmer to think about one game only. You need to think whether you're working on the tech side, like on the engine side, maybe system side, and think whether it's going to hit to 2 games or maybe only 1 game as a gameplay programmer. So it's kind of a different in terms of mentality, how to work, how to think about features, how to think about the architecture of the features. And we'll be talking about that a little bit more in this talk, but the majority of the talk will cover how the technical production is set up to really be able to do what we meant to do. And getting back to 2015 and even earlier, Dying Light 1 was made in trunk-based development, which means everyone was like creating the work on the single branch or single stream, or that was branch by then. We were using Perforce, and in 2015 there were no streams, so the single branch was used for all the development process. I mean, not only programming stuff, but also the content creators were using the same branch. In more details, we had something around 40 programmers, both gameplay programmers, system programmers, and engine programmers working on one environment, plus something about 80 content creators also using the same environment. We had approximately 250 submits per day, so like every 2 minutes or every 3 minutes. And some kind of we call it continuous integration, but this is like the automatic building procedure of testing the binaries that was checked into the perforce for every 15 minutes. Yeah, and we had some issues with the stability, as you can imagine, because we have 40 programmers on the stream. So the ideal number of programmers working on one stream is 0, because then they cannot break anything. You won't have any new features as well, but still, you can maintain the stability pretty easily. And we had 40, right? So it was like very unstable. We didn't have any automated tests, so we experienced the phenomena which is in credit debug. So anytime the programmer committed the bad code, someone was showing up like 30 seconds after or 1 minute that, okay, the editor is black. 80 people cannot work. Can we go home? Yeah, that was the situations. So as you can imagine, it wasn't a good environment for work. But still, of course, programmers were pushing to deliver new features, right? So they needed to submit the code. We had also nightly build procedure that was taking up to 4 hours, and that was the full build, which has been tested by the QA every day, like exploiting and finding some exploits and bugs. But this is like only for the whole build. Then during the day, we were just fighting with the submits like every 2 minutes. So after Dying Light 1 was released, we decided to, okay, let's separate technology development from the game development, from the production stream, not to break this production pipeline every day. So the idea was, like, in theory, something like that. Sorry for the CDU graphics. It won't be a lot of this. But I just make the visible part more important. We decided, in theory, to make the production stream, which should be stable. So going up, you have the more stable environment. And the development streams, going down, you have a feature set. So if you are going down, you have like a lot of engine stuff and new research and evaluating new technologies, new renderer stuff, new lighting system, and so on. And the idea is that we have several teams working like below, submitting the code into common trunk for pre-production. For UAT is user acceptance testing. So we wanted to test everything before it's going to the production stream, and then the content creators have very stable version because it's tested, it's verified. If there's like no new version or the new version does not work, we just don't push it up to the production stream. So that was the theory. And we ended up with a model something like this. This is the stream set up on the Perforce. So we have a tech main below here. This is our trunk for technology. We have a game logic here, which is like for gameplay programming teams. And we have main production streams on the top that are meant to be stable and are meant to release, to get really stable version of the technology, like the editor, executables, and all the toolset. This image contains already 2 games there, but we didn't know about the second game there, so we just wanted to make it theoretically, but everything was prepared for 1 game. And suddenly, after we figured the model for how to do it, there was a strategical decision of let's do 2 AAA games, of course stable, of course delivering technology on a daily basis, because new features, there are new features needed for Dying Light 2. So it was really a challenge, right? That this is like we are fighting that for 2 years and still trying to accomplish everything that should work perfectly. So to summarize, the premise, the goal that we set was, okay, we need to work on 2 AAA games simultaneously, sharing the same code base, because this is one that we wanted to achieve. So the games should be a little bit similar, but not too much. But still the engine part and the system part should be the same. Of course, at the same time, when the games are being in production or pre-production, we want to develop the technology, like pushing streaming, new animation system, new AI system, content generator for bigger worlds, new quest system because of choices and consequences in Dying Light 2. So a lot of systems that need to be delivered to the engine team, to the lower layer of the tech once 2 games are being in development. Of course, we want to maintain stability, so we don't want the situation from Dying Light 1 when like the editor was broken like 6 times a day. So we don't want to break production pipeline. There's like too costly for the company. When 80 people or 100 people can't work for 1 day, it's really costly for the company, right? So this is something we wanted to eliminate at the first place. Of course, to do that, to test the technology, we needed to invest in automated testing, and I'll show you a little bit more on that. And of course, we wanted to make developers happy, so if you make the environment too complex, they will be complaining that, okay, I did my work as a programmer, now I need to merge something, my stuff, why? I'm just a programmer, not the integrator, not the DevOps, right? So this is really important to make them happy because they are making features, right? So, and of course, at the end of the day, all features needs to be delivered in the common build because we're making 1 game or 2 games and not like the bunch of separate features. So we came up with the idea, we read a lot about different solutions, and we came up with the idea of feature streams. So you can divide your team into different streams, and they can work on their features without interrupting each other. So it's some kind of a stable environment for the AI, for the dialogue system, for the quest system, for the engine team separately. And this was our idea, so we still have the engine in the bottom with the different streams. We have core stream, we have tool stream, rendering stream. But for the game logic, so for the gameplay code, we decided to implement different streams for AI, for dialogue, for quest, and other systems in the game. But it didn't work properly because at the end of the sprint, for example, we came up with like 5 different builds or 6 different builds because each team wanted to show their work, and the integration between those was very painful. So it was something like this. We're trying to put everything into the common stream, but of course, it wasn't very easy to achieve that, not mentioning the hell with like fixing bugs and, okay, I fixed the bug, but on which stream? Yeah, I'm waiting for it, but I cannot merge because I'm waiting for another stream to be merged on the first place, right? So it was really a disaster, and it surely didn't make the developers happy. Maybe we weren't like breaking the pipeline, but the features were delivered very late because of the streaming and because of the integration process, which was very difficult. So we decided that in the future we want to go from the left side, from the feature streams, into something like which is called the one trunk. And a year ago we went in that state, and we wanted to go into this state. And this is something that I'm going to tell you a little bit more today because it started to work for us. So we got rid of the feature streams. Everything is on the trunk. You can still use feature streams, but it's like not very often practice to do that. So we encourage everyone to work on the tech main. And the final solution looks like this, so it's very similar to the right side from the previous slide. And I'll tell you a little bit about it right now, how it works. So we encourage every programmers for 2 games and for 2 technologies to work here. That's about the 80 programmers right now, right? So we allow them to check in their code on a daily basis once they're finished their work right away to this trunk. That means the submit like every 1 minute or every 40 seconds to the trunk. To maintain stability, because as we remember from Dying Light 1, it was not a very stable solution, but to maintain stability, we have a bunch of servers that checks the code every 3 minutes. We were able to introduce fast build to do that, and we are able to make the whole code rebuild in 2 minutes. So every 2 minutes we have the new executables that we can also test automatically, and this is very important. We implemented test complete, which is the tool that allows us to do the automated testing for the editor. So there is no more situations that the editor has not been tested once it's being delivered to the users. And this is very, very important, right? So there are no more situations when the editor is black or something is crashing at the startup. We were able to really figure it out on the tech main level. Going further, we have feature streams, but these are more like task streams, and task streams are very small streams just for the engine development. And if someone is working on DirectX 12 implementation, for example, it's like there is no necessity to work on that on the tech main. It takes some time, like 2 or 3 months to make implementation. It's not vital to the production streams. They are not waiting for this. So it's really good to have the task stream, but also we are trying to synchronize with the tech main very often, right? So we're trying to avoid merging hell, and that's the reason. We have a DevOps team, which is not so big. We have a team about 5 people that is responsible for delivering technology to the production streams and data from the production streams to the technology. Because we want the tech team, and this is not only tech team, right? All the gameplay programmers are also sitting on tech main. We want them to have the latest data because we want them to deliver features based on the current data, right? So one of the assumptions, one of the premises is that we want to deliver technology to the games on a daily basis and getting back the data on a daily basis as well, or on a weekly basis. It depends on the project needs or on the engineering needs, whether they need the new map or the new assets. It's up to them. And the DevOps team is responsible to do that. And in more details, they are working like that there is a local machine. And for example, we are syncing to the game one environment, integrating everything from the tech main. Once we know that after continuous integration tests, it's green, so we can integrate it to the production stream, and then push back to the game production the latest code. Then we have a updated production environment. And vice versa, on the other hand, we're syncing up to the tech main, we're integrating data from the production stream, and we can just push the data to the content folder for the engine creators, for the code creators on the tech main stream. And finally, on the production streams, we have all the content creators, which have the stable tool set, new features every day, almost every day, because we have something like 80% of efficiency when delivering technology to production streams every day. So that means that every week we can deliver at least 4 times new technology and new code to production streams, which is quite okay for us, right? Which is stable, of course, and that's very important. And now, trying to get everything together, what worked for us in that setup? Why it took us 2 years to get there? So first of all, don't use team streams, because at the beginning our feature streams were not feature dedicated, but they were team dedicated. So we had, for example, separate stream for tools team, and it's not good, right? Because they are working on different features, and every sprint they were uploading all the work from the team, from the tools team. And if there is a request for the tools team to fix something, they were fixing on their stream, but they couldn't upload it because the other features on that stream, on that tool stream, were in progress. So we needed to wait until the end of the sprint, which was not efficient at all. Yeah, so the bad lesson from feature streams or from the team streams was that we had at the end of the sprint, we had different builds with different features. AI team was presenting their achievements in different builds than the Quest system team, than the Direct system team, and we had the feeling that we are not making the same game, but many different games. And of course, those teams were depending on each other. For example, someone couldn't set up a test Quest because they had the new dialogue system, but they didn't have the Quest system, the latest version, so it was really pain. And fixing bugs was really hell because we didn't know where the fix is. When you ask the engine or system programmer hey, there is a bug, have you fixed it? Yeah, I fixed that on 3 streams already, and the issue was on the 4th stream, right? So we really got lost when on the current state of bugs, and it was really also very hard to manage that in the Mantis. We're using Mantis for bug fixing. Yeah, so nobody knew what is the current status, especially from the bugs perspective, right? There was these dependency issues, so one team was waiting for another to submit into the common game logic stream, but like it was no one wanted to do it because it was like merging into integration, which was painful. So it just didn't work. What we used, and we are using right now, and it worked, is use task streams under the trunk. So not higher in the hierarchy, but working on some engine features like rendering stuff, it's okay. Yeah, our continuous integration, it's not like the full continuous integration that you know from the IT industry, so it's not like integration when like everything is okay from the automated test, but this is like checking the current version of the trunk like every 2 minutes, seeing if everything is okay. This is like the photo from our room. We installed monitors showing what's the status of trunk. If there is like red, this is like a red alert. Everyone needs to fix trunk because we have 80 people working there. You cannot break people's work, right? So this is the red situation. We need to fix that. Later, like a couple of days ago, we've introduced even something which is automatically locking the tech main. So if the status is red, you cannot submit anything unless you are the one who causes the red alert, right? So you needed to fix that. And we're testing this, some kind of very hard rules not to submit to your features unless it's really fixed for the problem that is being right now. So we're doing code changes every 2 minutes. We are doing editor testing every 20 minutes. So test complete is being used there to verify those changes. So once we have the binaries, every 2 minutes we can just run the tests, and takes 20 minutes to really see the state of the editor. We also do the asset compilation to verify whether the changes in the code changed something, like there's like asset compiler has changed, so every asset needs to be rebuilt. Yeah, we're doing the nightly builds as well. They are taking right now like something like 3 hours, 3 hours and a half, which is important, and we achieve that. We're pushing the code, like hold the code, the engine code and the gameplay code to the production streams every day. This is very important. With the success ratio I mentioned, so there are like weeks that we're able to deliver every day. We've also introduced something which is get latest stable build. So you can sync to the latest green labeled submitted change list on the Perforce, right? So if you break the build and the continuous integration say, okay, it's become red from green, and there's like red, 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 you can sync to the latest green if you really need the stable version for your working environment. So this is the feature that we've introduced like 2 or 3 weeks ago. The lessons learned also is that the ideal situation is no merging at all, right? So once everyone is working on one environment, we can just submit to the trunk, and there is no stream merging unless it's a task stream below the tech main, but still we are trying to sync very often not to get any integration errors or just solving conflicts, right? So this is really painful as well. And in feature streams approach, we are constantly colliding with different work, touching the same parts of code. It was really a disaster. And yeah, the programmers were always can introduce some errors in their code, but the majority of issues that we experienced in the previous solution was not like the programming fault, but programmer's fault, but integrations, right? So they're like solving code conflicts was just really, really bad. In ideal case, as I said, don't merge at all, submit directly to trunk, and then solve potential issues right away that everyone can see what is the current status. And we have only one environment to maintain in terms of bugs, list of bugs, stability. We can put all the builders' power, let's say, to really try to test it from different perspective. And as I said, we introduced the automation for locking the trunk when it's broken. So you cannot submit more features to really hide this error. Also, as a programmer, you can claim that you are fixing the build. So on the monitor that you see here, you can claim that, okay, the trunk is red. I, Pawel, claim this build, and I will be working on that, so everyone knows in the company that I'm the one who tries to find the solution for that. Okay, we've also, comparing to Dying Light 1, we've introduced something which is called the Dev QA team. We didn't have in the past the dedicated team of testers that are focusing on testing the programmer's work. They are not just game QA, they are not like the functional QA or compliance QA. They are just testers working very closely with programmers to test those changes, especially when integrating from the substreams. So their job is to test majority of changes, like all of the bigger changes, and majority of small changes which are very vital. Like majority of hotfixes can be just put it into the trunk right away, but still, if you're a programmer and you're not sure whether this change is like critical or not, you can ask Dev QA team to test it. Then they can make a separate build on a separate stream and give you the information it's okay, or there are some issues with that you really need to refine. They are also writing automated testing procedures and keeping up to date, especially for the editor that is changing constantly because like 80 programmers are working on that, right? And besides automated testing, they're developing tons of useful tools like the telemetry system. So we know that, for example, we have on average 20 crashes per day on the production environment. We're still constantly fixing those, but then new appears. And using the telemetry, we know that this is something which is okay, because 50, it's not okay. Yeah. But 20 crashes per day, per team, which is like 80 people on the production, that means that every 4 people get 1 crash per day, which is acceptable in our case. Okay. Code reviews. Do you guys do code reviews? Who does code review in the company? Okay, nice. So 30%. So we didn't use that in the past, and we've introduced that lately. And we experienced that there's like different goals for the code reviews in our case. So the first thing is that it increases the communication between programmers. So each programmer is working on the same environment finally knows that there is some change in the code in the different areas of the code. Imagine that when using the feature streams, when each of the programming group was working like on the different streams, they're just say that I don't care what's going on the different streams. In my environment, everything is okay. But when we started to merge those stuff, it was like hell. So it's the first and the best way to communicate other programmers that, hey, I did this kind of a change. Maybe you should take a look into that because it's your code. You're the owner of this part of the code. We made it mandatory like a month ago. So you cannot submit the change to the trunk without specifying the reviewer. You can, in some situations that you are like doing the hotfix, for example, you need to put the tag no review. So without those tags, you cannot submit. So there is a perforce trigger that does not allow you to submit the code without one of these tags in the change description, right? Of course, if you are putting no review, you can do that always. But if it crashes, you're screwed. So everyone knows that you like took the responsibility of not specifying the reviewer and you broke the code. So this is like some kind of a mental pressure on the programmers to really check their code and really, if there is like not review hotfix, I really need to focus on that and try not to break the build for 80 other programmers working on the same branch. The majority of code review advantages is from post-submit reviews. So we are not blocking programmers before, unless it's like a bigger issue, bigger change. But it works as a communication, right? So after my change is being submitted, I've noticed it, people, that, hey, I've changed your code. It's already there. You can take a look into that. We can discuss, but it's already there. I'm not blocked. I'm not stopped before just submitting the code into the trunk. And also, seniors and juniors can learn from each other. So seniors can verify junior code when doing code review, and this is like being done either before or after the submit. But also, juniors can learn from seniors' code when they are doing the review for the seniors' code. Yeah, because they need to learn even different areas of the code, but they need to take a look and say, okay, that's the solution. I could use that in my code as well. So it works like that. And once again, majority of this advantage is that programmers are informed about the change, so there is no situations that, okay, someone changed my code, I didn't know about that. I need to know about that because I'll be the reviewer and someone will change my code. But the question is also about the task streams. So we are talking about the tech main, but as I was talking that before, below tech main, there are like DirectX 12, for example, task stream. So when to do the code review. And we decided not to do the code review when we're like integrating this task stream to the tech main, because it's like, it might change like 70% of the code, like if it's like refactoring or whatever. So we are doing code reviews on the task stream itself, right? So there's like small code reviews, and then during the integration process, we just ask the FQA to test everything, do the full tests, like the full build, bake the full build, play the build, and if it's okay, we can just integrate without any issues. And the sixth learning is that changes take time. So we were here, like, we planned to do this like last year. So this is the slide from the presentation from Reboot from last year, because that was the future that I was thinking of. And right now we are here, so this is very similar. As you can spot, there is one difference. I was thinking that the one game, which is closer to the release, should have their own dedicated team of gameplay programmers on their stream to really focus on the production. But we were able to make it even better. And right now, every programmer is sitting on the tech main stream, which is very, very good, especially when we're talking about exchanging gameplay programmers' experience and features that they're working on. And also, it helps in the terms of unifying the engine architecture, because everyone is sitting in one place. There's like no possibility to develop one game like more towards in some direction, but everyone needs to synchronize in a single environment. So this is really something that works for us right now. And the conclusions, just to summarize the talk, team streams just didn't work for us, so I really not recommending using that. Trunk-based development reduced for us the painful code merging and really allowed the programmers to focus on the feature development, not on the integration part. But still, programmers, and this is bolded here, they are responsible for technical quality of their work. So it's not only about developing features, but also developing stable features in the common environment. And this is very important. This is part of their job. They know their code. They're like the best guys to really make it work in the common environment. And this is their responsibility. Substreams, I mean the task streams below the trunk-based should be synced with trunk-based as often as possible to avoid merging differences in the future. So in ideal situation, when you're a programmer and working on new renderer, you could just get the data and the fresh code like every day, maybe every week, it depends on you. But you know that at some point you will need to put your changes into the trunk, so you should be really paying attention what's going on the trunk, just not to fall into some code conflicts later on. Continuous integration in our words and red alert visibility is vital. So once we install the monitors, we could really like put attention like, hey, this is like the red screen here. Please pay attention because there is your name on it who broke the build. So you should really leave whatever you are doing right now and really focus on fixing fixing this, because there is 79 other programmers that will come to you and say, please fix this because I can't work, right? Dev QA role also helped us a lot in increasing the quality of the delivered work. So this is also something important. As I said, about the responsibility is a very important part here. And also we've managed to do the automated tests, and that helped a lot. This is like an example. World Editor by the QA team was tested within an hour. We did very similar tests in Test Complete, and we can do that in 11 minutes, so it's a lot of way faster. We can also do it on multiple streams, so if you are doing on a task stream, you can just test the editor. You can test the editor on trunk, you can test the editor on the production stream as well, using the same script procedure, so it's very, very okay. We've also implemented some kind of a monkey bot. Monkey bot is a very simple player that plays the game and grabs the performance counters, memory usage, test stability into different parts of the game. So we can also generate these reports some kind of automatically every day. So after every nightly builds, there is a monkey bot report saying what's the performance, what are some key points of the game that has been tested. Okay, and at the end of the talk, short recap, so we'll see whether you were listening or not. So all programmers on the same stream reduce painful code. Merging, good. Code reviews helped us to increase flow between programmers. Communication, good. Programmers are responsible. That's the most important part of the presentation. If you needed to remember just only one thing, let it be this: responsible. The ideal number of programmers on a single branch is 0. Good. One of the games that Techland is working on right now is Dying Light 2. And my first name is Pawel. Good. Thank you very much for the talk. If you have any questions, I'm here. I'll be also till Sunday. Yeah, but this is the good time for your questions.
Yeah, let's do a Q&A.
Okay.
Hello, thank you for your talk. What happens if the DevOps team decovers an issue when they do the merging to the gameplay teams?
That's a very good question. Yeah, they're having a lot of work and getting the programmers involved in the issues to their local machines to really solve that. So we experienced the situation that, for example, we cannot merge this day. That's why I said that we have like 4 days in a week that with a success. But they're constantly resolving issues, right? So if there's like a conflict, but right now we have like very little number of conflicts, because on the trunk we are changing the code, and on the production environment we're changing the data. In previous, let's say, setup, where we were changing the code, in theory that was the gameplay code changing there and engine code changing here, but it was just a theory. In practice, we're changing all of the code here, and the merging was very, very painful. There was some situation that we couldn't merge for 2 weeks because of the changes. Yeah. Right now, it's not an issue. So if there are like issues, we like coming up with 2 or 3 issues per week. They're just solving the issues on the local machine with the appropriate developers. So they know, the team of 5 know all the 80 programmers, and then just calling them on a duty to fix this on a local machine and find out what's going on, right? But this is like the rare situation, like 1 per day, 1 per 2 days. Okay.
Okay, thanks for the talk.
You're welcome.
So, does it happen that you must integrate with some other repo? Like we have matchmaking services, they could change their API, and we can't work with develop stream. How do you handle problems like this?
Yeah, so we are using middlewares, not so many of them. To be honest, we are using middleware for audio and for video playback, and the rest of us is like ours. Of course, not mentioning zleep and other like common open source stuff, but everything is being done on trunk. So if there is like the new middleware, we're trying to integrate it directly on tech main, which is our trunk. If this is like a bigger change and it requires some refactor, we're creating the task stream below the trunk based. And that's the standard procedure. Of course, if it's a big change and we don't want to integrate, like going through the hell of integration, we are doing that directly on the tech main. And there is a possibility to lock the main for some time. Right? For example, we are, I don't know, changing tabs into spaces. And we need to touch 70% of the files or 80% of the files. We can just lock it, like for the afternoon, do the change on the tech main, submit it, and then it's like there. So this is the best way not to, to avoid merging. That's the first reason. But the second reason is to really do the fast situations like that require like huge amount of code to be touched. Is this answer your question?
Yeah.
Okay, good. More questions here.
So just two quick questions. So first of all, you mentioned at one point that all of your programmers are on tech main. So if I understood you correctly, there are absolutely no programmers on the game streams. So what about features that are different between the two games? Like what happens if game one needs a dialogue system, game two doesn't? And secondly, for the code reviews, you mentioned that you can't submit without the reviewer tag. But what do I do then if I write some code? Do I walk up to you, tell you, hey, come here and check out this code, and you manually come to my PC, review it? Or is there some sort of automated system that I submit my code to you, something like that?
Yeah, so starting with the code review, the code review is like just a name. You can do the code review in different ways. You can use the review board to really review the code. You can just talk to another guy and like talking, okay, I made a change I made a change like this, you said it's okay, we're just submitting it, but I put you as a reviewer, right, in the tag still. So it doesn't have to be the review that we all sit together in a team of 5 and looking at every line of the code. Sometimes it's happening because some changes in the kernel are very like sensitive, and there are need to be more directors involved in that. But we can agree that I'll just tell you about the change and that's it. Yeah, if we decide that it's not crucial, we can just submit it. So there are different levels of code review, but in general we call it code review. But still, you need to put a tag when in the change list description. Getting back to your first question, yes, we are working all on the tech main, but we have different folders for the game 1, game 2, and the engine. So all the programmers have access to all the code there, and you can just develop only one game in terms of the gameplay, not affecting the engine. But this is your call whether you're working on something which is common for 2 games or for 1 game specifically. This is maybe topic for another discussion or another talk. We have the solution also that we are working on right now that 1 game can inherit from another. So it's still 1 game is treated as a game framework, and on the top of that is the second game, and automatically you are getting everything from the first game, but you can make those games a little bit different. So this is the way that you don't have to integrate the gameplay code between 2 folders, right? Because you want to, in ideal situation, you would like to have the feature list here, and from architectural perspective, it's even better to put it here. You have 20 features here, but this game uses only 12, and this uses 15, for example, right? So we still try to make the engine big, the tech big, and the small game, which are just the bubbles and just the data-driven setup, how the features are being used and configured. So this is like the strategy in overall. Thank you.
Hi. How do you think your methodology of your work, how do you think it would scale on different team sizes? For example, a team double your size or a team half your size?
Mm-hmm. Yeah, so the idea is also to think about the future. So as I said, we're scaling from 1 to 2, but in theory, it's from 1 to n, when n is like 2 or more, right? So we really believe that this setup is scalable. We also work in a group of like 20 and 40 programmers there. Right now it's 80, and we really believe this is something which is scalable. Of course, if you have more programmers, you will probably have more change list in 1 minute submitted into the trunk. But still, maybe buying more builders just to to do more check-ins of the current state is okay. So I think for now, we don't also have plans to scale like in thousands of programmers or dev teams. So it works for now, and I think we're ready for a third or even fourth project right now. Yeah? And this is like the setup for us. We don't want to be like too general. We have also the technology which is tailored for some kind of games, and we want those games to be the best in terms of this technology, like this, not this, right? Yeah, but I think for the upcoming like 5 years or more, it will be enough and it will scale.
So are your features complete in 1 day? So if a developer starts working on a task like adding a new weapon or mechanic, can he complete it? Can they complete it in 1 day? Because in our team, it's more like at least 5 days of work to add a new feature.
Yeah, of course, it's up to programmer how much time it is required to complete a feature. But even if you're working on, I don't know, the feature which is like 2 weeks or 2 months long, you could still submit like parts of it. And we really encourage to do that, because if you are submitting the small chunks, you will not get like a full big merge at the end of the process, right? So it doesn't have to be complete feature, but of course you don't have to do it as well. If you prefer to have the local changes or the task stream, because this is like the bigger feature, or maybe this feature will involve more people, then this is like the good scenario for making a task stream and put like, 3 programmers there. It's okay, yeah? We don't have to we don't have a deadline for feature development. There are some features like DirectX 12 implementation that took 2.5 months, and it's okay. Yeah, and it was being submitted like every week into separate parts of the code, but still it was in the trunk already. So the final integration was very small because we every week does the integration, right? So.
Okay, and do you remove these parts of code that are yet incomplete by using feature flags or something?
No, we're try to update the code on the trunk as often as possible, right? If there are like new features and they are not completed yet, they are just not being enabled. And yeah, it's up to programmer. You can tag in the comment that it's not like ready yet. Or it's just not being submitted, right? It's up to the programmers. We have like from hot fixes, which takes you a minute, to big feature, which needs like 3 months and team of 5 to really accomplish. So we have like the full spectrum of it, and there are like no rules to do that. Yeah, it's up to you how to integrate it into the trunk, but the practice shows that more often you submit your parts of the work, your partial work, the less work you will have at the end when merging everything together.
Okay, thank you.
Thank you. Any more questions? No questions. Thank you very much once again. Thank you.